The production task comprises the technical data of the workpieces to be manufactured and the organizational data for workpiece manufacturing with influence on production. The technical data included the design characteristics of the workpiece to be manufactured. The geometrical shape mainly determines the selection of the production process. For example, round workpieces are mostly produced by lathing, prismatic by milling. The dimensions determine the structure and size of a production system. The quality mainly determines the selection of the production process. For example, grinding enables high dimensional accuracy and shape accuracy. The mass determines the structure and size of a production system, and the material mainly determines the selection of the production process, for example, injection molding for plastic processing. The technical data also includes the production-related characteristics of the workpiece to be manufactured, such as the raw part shape. The initial state of a workpiece, the raw part shape, determines its further processing and finish. If the raw part is of high quality, the finishing effort is small. Quality assurance is also an important production-related characteristic. Only precision machining processes allow measurements during machining, for example, during grinding using a measuring control. Highly flexible production technology enables broad applicability. Finally, if the production technology has the prerequisites to be automated, further development and streamlining of the production process are well possible. The important organizational data includes the following: the number of workpieces per year. It determines the overall production effort. The number of workpieces per batch, hence the batch size, refers to the quantity of similar workpieces that are considered a unit for the entire production process. It should be as high as possible so that non-recurring costs per batch, such as the preparation and completion of a work order, can be divided between many workpieces. The result is smaller unit costs. In contrast, the number of batches per year should be as small as possible, assuming the production equipment is fully utilized. This assumes a large batch size. For the number of purchased parts, no in-house production must be planned or realized. Suitable production processes and systems must be selected step by step. First, the variety of characteristics to be considered should be narrowed down for pre-selection of the production technology. For the organizational data, the batch size has proven to be the representative characteristic of a pre-selection. For the technical data, none of the specified characteristics can be considered as representative. Thus, they are investigated in sum first for pre-selection. If many parameters must be considered during the selection of the production process, the production task is highly complex. After a rough analysis of the production technology, considering the batch size and complexity of the production task, the final selection of production technology takes place considering quality assurance, environmental safety, and costs. Within the scope of production process design, the final selection of production technology can then take place. The in-house production possibilities should already be considered during the design of components and assemblies. This means that the existing production technology determines the production task to be realized in-house.